the process for sensors for MV2000. So first we have to make sure that the hardware is connected correctly. We have to make sure that the cable that is connected to B is the correct cable, and also this cable which is connected to A is the correct one. So how do we know? There's a number on each cable, and if we look at the data sheet of the sensors, it will say here sensor serial number. There's a certain number here, and the channel. So we have to make sure that this number is connected to this channel. Okay, so the number which is written here is connected to the correct channel. Then from here we also have a power supply, and we have to make sure, of course, the power supply is on, and we have an X and Y, B and C, which connect into the sensor X and sensor Y behind the DT controller. Now let's look at the software. Okay, so first we have to unlock this sensors here. So we go to software, unlock features, the number is 34674, we do OK, and now we unlock. So we're going to use for now the default file. Now where do we find it? We go into NWS, settings, scanners, and here we have the default. You can open it with a notepad, and you see here the calibration. How do we calibrate this file here? So we have to remember that our range is from 0 to 100 microns, and we want to make sure that the center is going to be the 0 position of the scanner. That means that 50 microns will be the 0 position of the scanner, because the scanner will move from 0 to minus 50 and plus 50 microns. So therefore, here we have to make sure that the 0 is the 50 here. That means it should have a value of 5.394. And therefore here we put 5.394. And 10 microns up, okay, so that will be the 40. That's 4.395. So here we have to put in 4.395, and we fill out the entire calibration file for the horizontal and the vertical direction. Then we save it. After we save it, we can see it in the NWS software at the sensors, okay, the default. And we should also see the values here. It could be that we don't see them immediately. You just have to turn off the software and then turn it back on. You should see the correct calibration values in this table here. Next step is to make sure that we have a calibration file. Now what I mean a calibration file is calibration and not linearization. So how do we create a calibration file? The same way like we do a regular calibration, we have to make sure that we have in the channels the x-axis and y-axis checked, and already if we're opening the input channels, also choose the sensor Y and also sensor X. Then we do a regular calibration procedure. We scan a calibration grid, and when we're done scanning, we choose with the cursor a certain area, which we know the dimensions. We go to calibrate, and then the important thing here is to choose calibration, not linearization calibration. We do calibrate X, calibrate Y. We give it a name, for example, test 2 or test 3. Wait. We don't press enter, we press OK. And then first we can choose here the correct Z calibration coefficient, because we're not dealing at all with the Z. So the Z has to do with the scanner and not the sensor. What we're interested in is the formula here. So we're going to choose test 3. Then first we're going to scan in the air. Now let's say that we want to scan, using the sensors later on, an area of about 20 by 20 micron. So first we're going to choose here 20 by 20, and we can scan in the air using first the formula for the calibration. We say there's a calibration file. So because we're scanning in the air, we can scan a bit faster. So the resolution should be about 200 pixels, and we can scan about with 4 milliseconds per point. And after we're done scanning, we go to hardware and we press calculate. Here you will see lines. Then we're done with the calibration, and we can choose sensors and scan using the sensors. Now let's say you want to scan a larger area using the sensors. So we have to do the last procedure again. For example, we'll again take the calibration formula. Let's say we want to scan an area of 60 by 60 microns. So we'll take 60. Again, scan in the air. When we're done scanning, press calculate, and then we can choose sensors. To make sure that the hardware is calibrated also correct, that means that this sensor is pushed into the correct spot, and also this sensor is pushed into the correct spot. We have to check that in the software. So we go to this channel, and we're going to choose sensor X. Now, right now we are in the 0, 0 position. For example, here we can also make sure we can press go and go to the 0, 0 position. And then here, when we read this channel, we have to make sure that when we read this channel, that the sensor X will be at 5 volts, because 5 volts is our 0 position. And if it's not so, we have to move very, very gently and slowly with an Allen screw the sensor inside here and see how this channel is changing. So do it very, very slowly, because we don't want to harm that sensor, and make sure that it's going in the correct directions toward the 5 volts. Now, in this direction, it's a little bit more complicated, because there's a stepper motor around here. So you might have to cut the Allen key in order for it to fit in the area to adjust the sensor.